The Triangle Inequality Theorem states that if you were to add any two sides of a triangle, they will always end up equaling greater than the third side. If we look at the image, we can see that we have a triangle that has side lengths 7, 8, and 9. If we look to the right, we'll see that if we were to add any two of the side lengths, it always ends up totaling, or the sum is greater than the third side. By knowing this information, we're able to figure out a couple of things about triangles. One thing that we can know is how the sides of a triangle can form a triangle. So when given certain sides, we're able to determine if, in fact, those sides will produce a triangle just by looking at their side lengths. The Triangle Inequality Theorem also allows us to come up with a possible length range of the third side if we did not know it. So let's go ahead and take a look at how that would work. Harry Potter, as you know, lived underneath the stairs of his family's house. The stairs of his family's house formed a triangle. And in this space, Harry Potter lives in, the triangle has one side of 5 feet and another side of 6 feet. However, we don't know what the third side is. Using the Triangle Inequality Theorem, we can figure out what x might be. If we were to add 6 plus 5, we would find out that 6 plus 5 is 11. This lets us know, based on the Triangle Inequality Theorem, that whatever x is, even though we don't know it yet, whatever it is, it cannot be 11 or greater. X must be less than 11. But if we subtract 5 from 6, we're left with 1. And that lets us know that whatever x is, it cannot be 1 or less. So whatever x is, it cannot be 1 or less. Given this, we are able to produce a range of possible solutions. We know that the side length could be 5 feet because it falls between 1 and 11. We know that the side length could be 10 feet because it falls between 1 and 11. We know that it could also be 2 3/4 feet because it falls between 1 and 11. However, we do know that it will not be 11. 11 is too large of a number for it to form a triangle properly. Let's look at another example. If we were to think about Domino's Pizza, well, Domino's Pizza, if we were to measure it, we could say that one side is 4 inches. On this pizza slice, we know that another side is 7 inches. Given that we know the two side lengths, 4 inches and 7 inches, we're able to figure out a possible range for x using the Triangle Inequality Theorem. So let's take a look. If we were to add 7 plus 4, we end up with 11. If we subtract 7 minus 4, we end up with 3. This lets us know that x is going to be less than 11, but it also will be greater than 3. So my answer is x is less than 11 and greater than 3. This gives me a possible range of what side x is, without telling me exactly what that length is. It can let me know that this is not going to be this is not going to be the exact length, but a range. For instance, we know that it could not be 12 because x must be less than 12, but we know that it could be 4. However, if we look at this pizza and we remember our knowledge about pizza and triangles, we know that this is an isosceles triangle. So the side x must be 7 because the two sides that are longer must equal each other in order to form an isosceles triangle. And if we look down at our inequality below, we can see that 7 would in fact fall between 3 and 11 inches. Our inequality has proven that our knowledge of triangles, as it relates to isosceles triangles, is correct.